Hello, in this video I'm going to demonstrate how to use strings in Java. Now string is a class provided by java.lang package and it is one of the most commonly used objects in Java. Now let's start by creating a project. Let's say using strings. We create a program under code.vinod package called program1. Here we create a string. Let's say we want to create a string str, and the easiest way to create an object of this is to assign something using double quotes. Now this is the most common way of initializing a string. For example, I'll say this is a string. Now since string is a class, you have to actually create an object. Now in order to create an object of this particular class, you should know what are the members in that. Now one way to find out the members in a class is by selecting that and pressing F4, function key 4, and that will give you what is called as a type hierarchy. And in the type hierarchy you can see what is the class name, what is its superclass, what are the members of that, and so on. And you will also get to know each of the methods, whether they are public or static or final and so on. For example, you can see that there is a S and F. S indicates it is static, F indicates it's a final, red indicates it is private, green indicates it is public. Now you can see that there are plenty of functions and so on, but you can also look for some constructors. Now there is a constructor which doesn't take any argument. There is a constructor that takes byte array as an argument. There is a constructor that takes something like a character array. There is also a constructor that takes another string object itself as an argument. And some of them are deprecated here, which means you're not supposed to use them for better performance. So now the proper way of creating an object here would be new string and say this is a string or string object. Now while this is the correct way of doing or proper way of doing, we encourage not to use this. Now there is a reason behind this. Let's understand this by using string1, or probably I'll use a name here. So I'll say string name1 equals to Vinod in quotes. And then I'll check here string name2 equals to Vinod once again. Now what has happened here, according to what we know so far, we think that this has created one string object and this has created another string object. But in practice, that is not the way it works. Now this has checked in an internal pool of strings, is this particular string available? If it is available, it is going to just get the reference of that string object. Now since this is the first time Java runtime environment has encountered this string now in this particular session, so it is going to create this and store it in the pool and gets you the reference of that. So we got that reference. So an object was constructed over here. So you can say new object was constructed here. Whereas when it JRE encounters this second time, this time it is going to go and check in the pool, and the previous statement has already created such an object in the pool, and it just gets the reference. So no new object here. So if I go and check, is name1 and name2's references, are they same? So I can check here by using name1 double equals to name2. Now this is going to compare references. So I'm going to go print that is plus this comparison. You will see that it's going to tell me that it's true. They are same. As you can see, name1 equals to name2 is true. So does it mean if I go and use this variable and change one of the character here, does it affect this? Now in theory, yes, it would be possible, but it is not possible for you to change the value of a string once it is created. Now this is why strings are considered as immutable, so you will not be able to change that. Now let us understand that in another way. For example, if I say name1 dot, I will call a function called toUpperCase. Now we assume that, or we may think that toUpperCase, if you call, this will be converted into an uppercase. Now let's just go and check, is it really true? We'll say name1 is equals to name1. When I execute this, you will see that the value still is in its original format. That is because when you call this particular function, it created a new string object with exact copy of this and then converted that into uppercase and returns that. The returned value we never stored anywhere. So if you want to store, you can say name1 equals to and call this. Now you see, now the returned object is a new object. The new object has been assigned to this older reference. The earlier object is now detached from this. So name1 is no longer pointing to that particular object. So if I execute now, you can see that it is in uppercase now. So strings are immutable. Now we can also compare the same thing with using something like this. We go and say name1 equals to new string of Vinod and name2 equals to new string of Vinod. And as you can see that we have got two string objects. Unlike in the previous case where a new object was created by the JRE conditionally, whether it existed already or not, in this scenario it is not the case because we said, hey, I want a new string. Now the new string will borrow the values from this particular reference, and remember this is already in the pool, so from the pool the values are copied and into a new string object, and this also goes in the same way. So both of them create a new object in this scenario. So if I check now whether name1 and name2 are pointing to the same object, the answer would be false because they are not. They're not pointing to the same references. So that is why we generally say use this. Now sometimes we might come across with a function that receives a string and we would like to check if that string is equals to or not equals to and so on. Now it is a good idea to convert both of them into a what is called intern. So I can say name1 equals to name1 dot intern and name2 equals to name2 dot intern. So basically what we're doing, we're just trying to say, hey, if the value of name1 is already found in that internal loop or internal pool of strings, just get that reference and discard the current object. So ideally the object which has got constructed here is now ready for garbage collection, and so does this also. So when I execute now, you will see both name1 and name2 are now pointing to the pool, and the pool contains only one string Vinod, and that is equal. So when I execute this, you should see that it is true. Let us also look at some of the functions in the string class. Now, one of the things that you would like to probably do is to check if two strings are equal or not. For example, when we check here name1 equals to name2, so we check here something like this, if name1 double equals to name2. Now this is a wrong way of comparison because both of them are two different objects and the references don't compare. So we say here that name1 and name2 are same, and we'll give here else system.out.println, we'll say name1 and name2 are different. When I execute this, you'll see that it says it is different, and it's different because this is a reference check, not a value check. So to compare the value of one string with another string, irrespective of whether they point to the same reference or so, we prefer to use name1 dot equals name2. Now when you execute this, the values are being compared and it says they are same. So never compare strings with double equals because that is not predictable. And so you always use name1 dot equals name2. Now similarly, we can also compare two strings whether they are lexicographically higher or lower values. For example, if I create string name1 equals to Shyam and string name2 equals to say Shailaja, and now if I want to check which one is alphabetically or lexicographically lower than the other, I can check like this. Now this is where you get a value called a compare to value. So we'll say name1 dot compare to name2. Now this returns a number that indicates whether it is a negative, whether it is the first string, that is name1, is less than name2, or name1 is equals to name2, or name1 is greater than name2, by returning a negative, 0 or positive. So by checking that, we say if C is less than 0, that is negative, then we can say that name1 is less than plus name2, and else if C greater than 0, then I can check name2 is less than, or probably I can say name1 is greater than name2. And obviously, if it is not less than 0, not greater than 0, it is equals to 0, then I can say name1 and name2 are same. So I'll say both names are same. And when I execute this, it's going to check between Shyam and Shailaja. And the way this works is that it's going to compare S and S. So it's the ASCII values or Unicode values of S is same. So that's going to 0. Then H minus H is 0. Y minus Y is 0. A minus L is a negative number, and that negative number is going to be assigned to C. And it's not going to compare with M and JA here, or AJA. Now, similarly, if I'm comparing the other way, so it's going to compare in the reverse order. So let's go and check this out. And you can see it's going to say Shyam is less than Shailaja, or, and that's basically lexicographically. Whereas if I type here Shyam and Shyam, both of them, then in that case, the return value happens to be 0. It says both the names are same. The string class offers so many functions that are very useful. We already saw an uppercase. Similarly, you have two lowercase. But you can also check the existence of one string in another one. For example, let's say I give str equals to the quick and the quick brown fox jumps over a lazy dog. So we got some string, and we want to check where is the word fox starting from. So I can say something like this. So I can call this as a stack, and I want to search for a needle. So I'll say, what is that I'm searching for is fox. So I can check with index of. So I'll give here int c equals to haystack dot index of. The string that I'm looking for is needle, and that gives me an index of this particular letter F within this. So I can print index equals to plus C, and you should get that particular index, and it says 16. Now you can count the number of characters, and you will see that the position here is basically 16 starting from 0. Now if you want to find out from that particular position where is that, let's say for example there is another fox here, so lazy fox, and I want to find the second one. You can also say starting from this particular index C, where is this needle? So I can say haystack dot index of, and then I can give a from index. So I can give here a needle, and then the from index is C, but I can say C plus 1 because in C anyway there is one fox. So if you give here C itself, then you get the same thing because that's where it was found. So we want to skip that character. So you can see that it says 16. So I should say 16 plus 1. So from this point forward, is there a fox over here? So if that is the case, I'm going to get that output. So in fact, the plus 1 was supposed to be in the index of. So when I execute this, you can see at 16 I have one fox, at 38 I have a fox. So if I want to find out how many times this fox is available, I can loop through and find out. For example, I have here who is a friend of another fox. So I'm having here a bunch of foxes, and I want to now see how many of them are there. So what I can do, I can use this particular int c equals to int c, and then I'll check here while c equals to haystack dot index of this particular word fox starting from I plus 1, where I is supposed to be initially 0, or probably I can say C itself, so C plus 1. And now what we need to check here is that we get that index, but if it is not found, this is needle. Now if it is not found, now we need to stop the loop. Now when the needle is not found in the haystack, or the search string is not found in the original source, then it returns a -1. So we check that if it is not equals to -1, then you continue the loop. So we are basically getting what is the index. If the index is not equals to -1, we continue. And in here, probably I can print int count equals to 0, and then I say count plus plus. And then I can say that the word fox, which is in the needle, is found, I can say count times. So let's see if I can get the correct output. Of course, this is needle is not initialized, so we'll say needle is -1, meaning we start from the 0 index and then continue to accept. Let's just check if we are going to get this. It says that the word fox is found 3 times. Now let us move on to some more additional functionalities available in string class. Now string class provides also functions like last index of, which works exactly like index of, except that it starts from the right side of the string. So take some time out and try the last index of. String also provides functions like concat. For example, I can say string str equals to an empty string. Then I can say str dot concat of something like my name, and then I put a dot concat of a space, and I type here, maybe I can just type here some dot concat of Kumar, and then I will say dot concat, and I can go on and on and on. So a space, and then I'll type concat of, say, Bangalore. Now this whole thing, the entire statement is of no use until you assign something, because you remember string is a immutable class or immutable object. So I have to say str equals to str and so on. So I can call this concat as many times as I want, but then of course it returns always a new string. So I can type str. So when I execute this, you should see that it says Vinod space Kumar space Bangalore, and that's because of this particular concatenation. Now if you want to find out the length of the string, you can always find by using the length function. So str.length is a function that will tell you how many characters are there in a given string. So for example, there are 21 characters in the concatenated version of this string. You also can use uppercase lowercase conversions by using str.to uppercase or to lowercase and so on. Of course, since it is already in lowercase, there's no meaning in converting that into small letters. So I'm just going to go give here as capital letters. So I got that. Now you can also say something like, say for example, I want to check if a particular index, what is a character. I can say something like character at index 5 or probably 3 in str is, and then I type here str.char at 3. Now note that the index starts from 0, so you're going to start from 0, 1, 2, and 3, and that happens to be the letter O. So when I execute this, you will see that it says the letter is O. So these are some of the most commonly used functions in string class. I hope you learned something.